Did you do it? Did you name it? Well, I hope you did, because there's no excuse for you not to name it. I mean, what did you do in the break since you hit the stop button in the last video? I mean, other than go get something to drink or go use the bathroom or go to sleep, and who sleeps nowadays anyway? So if you are back at this video, I hope that you at least attempted to give me a name for this structure. All right, because now's the time where we're going to double check your answer. We're going to see if you're correct. So we'll go through and we count the number of carbons, and we do 1, 2, 3, 4, 5, and 6. All right, so with those 6, this is a hexene. I'm on my way to a correct answer. Okay, so there's 6 carbons. I have an ene group, don't I? So where's my double bond? Oh, wait. There's 2. There's 2 double bonds. All right, well, how do I number this? I give my double bonds the lowest group number possible. Well, I just so happen to do left-handed to right-handed. And if I did that, that will give me a 2, because this carbon is the first one in line to get the double bond, and a 4. So it's 2 and a 4. All right, well, what if I go the other way? 1, 2, 3, 4, 5, and 6. Oh, okay, so 1, 2, 3, 4, 5, 6. So at carbon number 2, that's where my first double bond's at. And then at carbon number 4, that's where my double bond's at. It didn't really matter. 2, 4, 2, 4. I get the same number no matter which way I go. All right, so I know that this is a 2, 4. So 2, 4 what? It's a 2, 4 hexene? No, it's not. It's not. Because that means 2, 4 hexene, you've only spelled out, you've only included in the name 1 double bond, not 2 double bonds. So that means I'm going to have to go back and I'm going to have to modify my name. And the way that we do this is I'll erase it. There's 2 double bonds. So we're going to put di, that represents 2. And then we write the word ene, diene. It's a diene. And I know that you're dying for more examples. Or maybe for this to be over with. Who knows? But 2, 4 hexdiene, that sounds kind of silly, right? Hexdiene. Well, but for that reason, I mean, if you wrote hexdiene on an assignment or a test, I give you credit. But 2, 4 hexdiene, it doesn't really smooth off the tongue that well, does it? It's like a foreign language. You want it to roll off of your tongue. You don't want to put effort into saying these names. 2, 4 hexdiene sounds a little silly, so that's why we put an A in there. Hexadiene, and you can see where hexa kind of comes from, hexane in a way, but we just put that extra little letter in there just so that it sounds a little bit better when we say it. 2, 4 hexadiene. Doesn't that sound better? 2, 4 hexadiene versus 2, 4 hexdiene. You almost have to pause when you say that name if the A is not present. So 2, 4 hexadiene is the appropriate IUPAC name, but if you leave that A off, it's no big deal. You're close enough. I give you credit. I'm not that picky, at least when nomenclature is concerned. All right, so let's try another. All right, so another one, CH2, double bond, CH, CH2, CH, double bond, CH2. So let's name this one. You name it first. Put me on pause, and then play me when you're ready. Okay, so let's check your answer. Let's see what you ended up with. All right, in total, 1, 2, 3, 4, 5. So this is a pentene, because there's a double bond. All right, how do I number them? Left to right, right to left. Folks, it doesn't really matter. It's the same. Don't trust me? Do it. Number from left to right, and then number from right to left, and you'll end up with the same numbering system no matter which way you go. It is a tie as far as the double bonds are concerned. So on carbon number 1, there is my first double bond. And then on carbon number 4, there is my second double bond. So it's a 1,4-pentene. Wrong. It's not a pentene. And the reason is because there's 2 double bonds. So I'm going to have to erase this ending. There's 2 of those. So this is a diene. And I could leave it as 1,4-pentadiene. But notice how awkward that sounds. Try to say it out loud. You'll actually see your mouth pause you for a minute to try to get out all of this. And for that reason, we still include the A there to bring these 2 pieces together. So 1,4-pentadiene is going to be the name of this structure. All right, let's do another. Let's do CH3. CH, double bond, CH. CH, double bond, CH2. Just like before, pause me, go take a stab at this, and then come back and see if you're right. Okay, so let's double check your answer. Longest carbon chain, 1, 2, 3, 4, 5. So this is another pent. So pentene. There we go. I got to figure out how to number it. If I number from the left, it looks like I'm going to start further away from those double bonds, doesn't it? And I do. So if you do want to prove to yourself not to go left-handed to right-handed, then write out those numbers. 1, 2, 3, 4, 5. And then from the right-hand side, we've got a 1, we have a 2, we have a 3, we have a 4, and we have a 5. So at carbon number 1, I see my double bond. At carbon number 3, I see the first encounter of a double bond or a sp2 carbon, don't I? Oh, look what I did. Sneaky, sneaky me. I went back to lecture 1 and I brought in hybridization. So we're looking at the locations of the sp2 carbons. That is what the IUPAC names are really wanting me to do. I'm identifying the sp2 carbons that are associated in a molecular structure. Ha, look at there. All right, so at carbon number 1 and at carbon number 3, I have a pentene. Well, not fully, and as you can imagine, there's 2 of those double bonds. So I'm going to put the word di, and I'll write the word ene, and because of that, I put the little a in there. So 1,3-pentadiene. That is going to be the IUPAC name for that structure. All right, so I've done examples that are involving 2 of them, right? So keep in mind that you could have 3 double bonds. That would be called triene. You could have 4 double bonds, and that would be called tetraene. All right, and that's typically where we stop, especially in the first semester of organic. And the reason is because we typically deal with smaller structures that aren't very large, and it's very uncommon for me to get more than 4 of the same type of group that's in a molecule. So di, tri, tetra, it's typically where we stop. And with any assignment or with any test that I decide to give out, it's probably going to be the maximum number that you're going to see anyway. If you did 5, it goes back to penta. If you did 6, you know what that one's going to be. It's going to be hexa and so forth. So the di, the tri, and the tetra really are the 3 that do change as far as prefix is going to be concerned. Okay, so let's do another example. This time I'll just do a skeletal structure. I'll just keep flipping it back and forth on you to get you used to it. So here's a zigzag, 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 zigzag. We'll do a double bond here. We'll do a double bond there. We'll kink this one up right there. Okay, so we have to name this structure. Again, pause me. Try it. If you get it wrong, you get it wrong. No big deal. And then come back and we'll double check your answer. Okay, so I need to find out what my longest carbon chain is going to be. And that longest carbon chain has to include as many of the double bonds. Did you catch that? As many of the double bonds. as possible. So there's going to be a chance that I could get a vinyl or allyl group that comes out of this. We just haven't seen those yet, but I could, and that's one of the reasons that they might show up. Maybe it doesn't include all of them. All right, so here we go. It looks like my first carbon, second carbon, third carbon, fourth carbon, fifth carbon. If I go up, that's 6. If I go to the left, there's 6 and there's 7. So it looks like this is my longest carbon chain right here. So I'll circle it. That way we'll know what to name a little bit later. This is a heptene because there's a double bond in there. I number closest to the double bonds. It looks like they're all scattered over, or not scattered, but it looks like they're all located over here to the right-hand side, which is why I started my number 1 spot there. So at carbon number 1 and at carbon number 3, I find my 2 double bonds. All right, but they're 2 double bonds. So I'm going to erase the ene, and this is going to be a diene because of that. And I still put that little A in there. Hexadiene, pentadiene, butadiene, heptadiene. There's no difference. So I still put the A in there to let it roll off the tongue a little bit better. And then at carbon number 5, I have a group. And the name of that group, that is a 1 carbon. Therefore, that is called a methyl group. So 5-methyl, 1,3, heptadiene is going to be the name of that structure. All right, another example. We get a ring. All right. So once again, pause. Take a stab at it. We've not done any rings up to this point as far as enes go, but take a stab at it and see what you get me. And then push play and see if you're correct. Okay, so we're back. We need to now go through and figure out what the proper IUPAC name of the structure is. My longest carbon chain that includes the double bond, it is going to be the ring structure. It's right there. So I'll circle it. I know that this is called a cyclo. Well, it's a cyclo what? Well, there's 5 carbons that are involved in that ring. So this is a cyclopentene with a ENE ending. So cyclopentene. All right, now the issue here is that I got to figure out a number to give the double bond, and I forget about all the other substituents. It's the double bond priority right now, right? Okay, well, here's the thing. Some people will say, hey, if I put a 1 here, then if this is the 1 spot, there's a double bond, and then here's my number 2 spot, and that ethyl group would get a 2 spot. Okay, well, that's wrong. The reason is because you have to go through the double bond in order to fully count it. All right, well, if I put the 1 here, I didn't go through the double bond. I bypassed it. I know I started with that sp2 carbon, but you have to include the entirety of the double bond in the numbering. So that is not going to work for you. And what that means is that my number 1 spot has to go to this carbon that's right there. And then I have to go through that double bond in order to properly count it as a double bond. So that forces this spot to be number 2, which then forces that spot to be number 3. So my double bond happens at the 1 position, 1 cyclopentene. And then at the 3rd carbon, I have the ethyl group. So 3 ethyl, 1 cyclopentene. And I can leave the 1 off if I want to. It's understood to be there if there's no number that's present. But I do include it. I think it helps you early on in organic. So I tend to keep that around whenever possible. All right, so there you go. That's how we treat double bonds in a ring. You have to go through the double bond for the numbering to count. All right, so let's do another example. This time, we'll do that. We'll put the double bond here, and we'll draw a group here, and we'll draw a group here. and it's up to us to figure out a name. So you pause me just like before, try it, see what you come up with, and we'll see if you're correct. Okay, so we need to double check your name for this structure. Well, the longest carbon chain, that includes the double bond, that is going to be the ring system here. All right, so this is a cyclohexene. Well, I need to go through the double bond in the numbering in order to count it because there's other substituents that are on this group as well, the structure. So I've got to figure out, is there a way to give me the lowest number possible? So no matter what, if I start here with number 1 or there with number 1, this is going to be a 1 cyclohexene, no matter how I look at it. That is going to be the very first location of that double bond. I just got to figure out, are the methyl groups going to cause me a problem? Will it help me determine which way to go, or are they even? Are they going to give me the same story? So if I change my color, let's say that we start with 1 here, we'll automatically have to go to 2 there. We have to go through the double bond. This will be carbon 3, this will be carbon 4, and that will be carbon 5, and that will be carbon 6. So my methyl groups here will happen at spot 4 and spot 5. All right, well, what if we go the other way? So what if we start with 1 here? Well, by default, I have to go through the double bond, and this will be spot 2, this will be spot 3, that's spot 4, this is spot 5, and this is spot 6. And those methyl groups are still at spot 4 and 5. So it doesn't really matter how I number direction-wise with this particular molecule, because they're going to give me the same number for my methyl groups. It also gives me the same number for my double bonds. So, with that said, that means if we keep it the first time that we did it, counterclockwise, at spot 4 and at spot 5, I have 2 methyl groups, don't I? So this is 4, 5, dimethyl, and then 1 cyclohexene. One more time, I can leave that 1 off. It's understood to be a 1 if it's not there, and it cleans up the name. It makes it a little bit shorter, but I do have a tendency to keep it. Your textbook does not. Blackboard might not. But on a test, if you give it to me, I count it right. If you leave it off, I count it right, because that 1 is not a have to. You do not have to put it there if it's a 1. All right, let's do another example. Similar to the last one, but a little different. Okay, so just like before, put me on pause. Try this at least. Just takes a minute, less than a minute. And then hit the play button when you think that you've got the correct name. All right, so let's double check your answer. Let's see if you're right. So with this structure, my longest carbon chain, that includes the double bond, will be the ring. So I'll circle it. All right, so over here, this is going to be called a cyclohexene with an E-N-E, because there's 6 carbons in the ring. And this is called a methyl group. I know that. This 2-carbon system, that's called a ethyl group. I know that one. If I go into the name and begin to write this out, my E comes before the M, so I can go ahead and write that in the proper location. So here we go. Ethyl, then methyl. I got to figure out what numbers go where. I mean, that's really what this is all about now. All right, so in the numbering, let's try it. Do I start the carbon here and go through the double bond to go there and then continue to go around? And I hope that you would tell me no. And that's because the methyl and the ethyl will happen closer to the end of that numbering system. So just based on that alone, and if you don't believe me, write down the numbers and see what numbers you get. So because of that, I'm going to start number 1 carbon right there. I go through the double bond, which forces that to be number 2, and then I'll work clockwise around. That makes this 3, this one 4, this one 5, this one 6. Therefore, at carbon 3, I get my methyl group. So this is a 3. At carbon 4, I get the ethyl group. So a 4 goes there. And then at carbon number 1, of course, that is where my ene group is at, right here. But this time I'm not going to put the 1, just so I can prove a point to you that I don't need to write it. So 4-ethyl, 3-methyl, cyclohexene is going to be the name of that structure. Now, once again, I don't want you to get lost, meaning that you also have to be comfortable going from this name to this structure. 4-ethyl, 3-methyl, cyclohexene. Okay, well, let's just work backward a little bit on this one. Cyclohexene, what does that mean? Well, that means you draw a 6-membered ring like that. Mine's a little wobbly. Not very distinct, is it? This one's even wobblier. Who knows? There's my 6-membered ring. My hand's getting lazy. Cyclohexene, just put it somewhere. Put the double bond somewhere. It doesn't matter where. Just put it in there. And by default, this is spot 1 and this is spot 2. So on carbon 3, which would be here, you've got a methyl group. There you go. At carbon 4, you've got a ethyl group. So there you go. You've just drawn the structure. That's all that you need to do with those, all right? So be able to go both ways, back and forth, because that's going to be pretty important. Here is just another example of some different names that have multiple double bonds in them. I'm not going to draw these. The one to the left-hand side, this has 3 bonds in them. And if you look at this ring, it is a 7-membered ring. So cyclohepta, that's where hept is going to come in. It's 7 in total. All right, at spot 1, at spot 3, and then at spot 5, that is where you see the double bonds. So 1, 3, 5 is in the name for that reason. And there's 3 of them that's here. So that is why we see the word tri. So 1, 3, 5, cyclohepta triene is going to be the name of that structure. Over here to the right-hand side, this one's a little dirtier. It's a little bit more beastlier. There's a lot more groups on it than what we've seen before in the past. However, it's still a 6-membered ring as we go around, so I see cyclohexa in there. It is 2 double bonds, so that's why we see diene. And just because I have to start at a double bond, where do I start? If I start it here with spot 1, and then 2, then 3, then 4, then 5, then 6, then I'm going to get a 1, 4 cyclohexadiene. And if I did it the way the problem shows me in PowerPoint, I still get a 1 and a 4 cyclohexadiene. So the double bonds here are not really playing a factor as far as the numbering goes. All right, I want you to understand that. It's the same no matter which way you number. So what does determine this, though, are the other groups that are on there. And the other groups, if I start it with my first carbon here, that would be a 1, and then a 2, then a 3, then a 4, then a 5, and then a 6. So this would give me a 5, a 6, and a 6 for those 3 methyl groups that are there. Right? So the reason that they numbered the way that they did here in the problem is because if they start with carbon 1 at this spot and then do 2, 3, 4, 5, 6, this case I get a 1 and then a 6 and a 6. So because this is a lower group number, 166 is the preferred way of numbering that chain, and this is a trimethyl because I have a methyl group here, and I have a group there, and I have a group there. So 166 trimethyl, 1,4 cyclohexadiene. All right. So with that said, we'll stop it here. I think we've done enough examples in this video. And what I would like to do in the next video is force you to go from a name to a structure. I've already kind of alluded to that just for a second, just a past slide really. And we're going to continue that concept. So when we come back, we will draw these structures out. And if you want to, pause the video, write down these names that you see here, and then work on those. And then when you push play on the next one, you'll figure out if you've drawn them correctly. So this is what we'll do when we come back in the next video.